Seaborn is one of the powerful Python library that makes it easy to create informative and attractive data visualization in Python. So welcome back to Excel Island and welcome to this data analysis in Python career journey, which is 100 days of Python, where we are looking to learn and master Python over the next 100 days. Now we are on the eighth course in this whole learning journey. So we are on to the course called Introduction to Data Visualization with Seaborn. We are going to be learning how we can use Seaborn to create a variety of plots such as scatter plots, count plots, bar plots, and box plots. And now we can actually customize our visualization in Python, just like the way we did in Power BI in Excel. Just like the way you customize your data visualization in Excel or Power BI, you can bring same knowledge into Python with one of the Python library for data visualization, which is Seaborn. So welcome back to the channel. So if you're looking to start your learning journey in Python all the way from day one with a good resources, I have a live stream on the YouTube channel where we started all the way from day one from Python basics all the way till today, day 53. And the goal is to complete the whole lesson, the whole curriculum within 100 days of learning. So as it is, we are actually on track. So the data set we'll be using for this new course, which is data visualization with Seaborn, is linked under the YouTube description. So this data visualization with Seaborn actually contains 4 chapters. So hopefully over the next couple of live stream, we're actually going to complete this whole lesson. Let's go to the career tag section real quick. You can see we're on data analysis in Python. We're actually 55% throughout the whole career tag. So we're kind of more forward. We're not lagging behind. And today is day 53. So I have like 3% chances of completing it before day 100. 3% more chances. And that is high. Yeah, of course. That's actually calculated correctly. So I click on this data analysis in Python. Let's see what we have here. So we're actually on the 8th course. You can see we're on the 8th course. We just have a couple of more courses to go. We have course number 9, 10, 11, and the rest are projects to make it 15 in the whole curriculum. So I just click on start course. So I have my Jupyter notebook already launched. Let me just go to my data file here. Let's go to data camp resources. So my Python for data analysis. We have our data sets already. That's it. So we have the data sets, countries of the world, this MPG, which is miles per gallon. I think that is giving us information about fuel or fossil. We also have students' alcohol consumption and young people survey. So these are the 4 data sets we'll be using in this data visualization with Seaborn course. So all this will be available in the link under the YouTube description. So you can also download these files and practice your visualization skills also. So without any other delay, let's see what we have. We have introduction to Seaborn, where we're going to know what is actually Seaborn and when should you use it in this chapter. Then we have the next chapter, visualizing 2 quantitative variables. We also have visualizing a categorical and quantitative variable. We now have customizing our Seaborn. So normally in your data set, you have uh, quantitative variables and qualitative variables and categorical variables. So let me just put on my headsets so we can get started. Just a second there. So the goal is to use probably less than hour, 45 minutes, 1 hour daily to take lessons little by little all the way till day 100. So maximum of 1 hour. It doesn't pass 1 hour. So let's get started. Welcome to the live stream.
Hello. Welcome to this introductory course on Seaborn. My name is Erin Case, and I'll be your instructor. So what is Seaborn? Seaborn is a powerful Python library for creating data visualizations. It was developed in order to make it easy to create the most common types of plots. The plot shown here can be created with just a few lines of Seaborn code. This is a picture of a typical data analysis workflow. Data visualization is often a huge component of both the data exploration phase and the communication of results, so Seaborn will be very useful there. There are several tools that can be used for data visualization, but Seaborn offers several advantages. First, Seaborn's main purpose is to make data visualization easy. It was built to automatically handle a lot of complexity behind the scenes. Second, Seaborn works extremely well with Pandas data structures. Pandas is a Python library that is widely used for data analysis. Finally, it's built on top of matplotlib, which is another Python visualization library. Matplotlib is extremely flexible. Seaborn allows you to take advantage of this flexibility when you need it, while avoiding the complexity that Matplotlib's flexibility can introduce. To get started, we'll need to import the Seaborn library. The line import Seaborn as SNS will import Seaborn as the conventionally used alias SNS. Why SNS? The Seaborn library was apparently named after a character named Samuel Norman Seaborn from the television show The West Wing. Thus, the standard alias is the character's initials, SNS. We also need to import matplotlib, which is the library that Seaborn is built on top of. We do this by typing import matplotlib.pyplot as PLT. PLT is the alias that most people use to refer to matplotlib, so we'll do that here as well. Let's now dive into an example to illustrate how easily you can create visualizations using Seaborn. Here, we have data for 10 people consisting of lists of their heights in inches and their weights in pounds. Do taller people tend to weigh more? You can visualize this using a type of plot known as a scatter plot, which you'll learn more about later in the course. Use sns.scatterplot to call the scatterplot function from the Seaborn library. Then, specify what to put on the x-axis and y-axis. Finally, call the plot.show function from matplotlib to show the scatter plot. This plot shows us that taller people tend to have a higher weight. How many of our observations of heights and weights came from males versus females? You can use another type of plot, the count plot, to investigate this. Count plots take in a categorical list and return bars that represent the number of list entries per category. Use the count plot function and provide the list of every person's gender. This count plot shows that out of the 10 observations we had in our height and weight scatter plot, 6 were male and 4 were female. Now those were a couple of simple examples. Throughout this course, you'll learn to make more complex visualizations such as those pictured here. More importantly, you'll learn when to use each type of visualization in order to most effectively extract and communicate insights using data. I'm excited to dive into Seaborn with you throughout this course. For now, let's practice what you've just learned.
Oh, good. So let's practice. So before we continue, I always love to also practice in my own Jupyter notebook here, my local computer, so I can actually know what it feels like to work in my own environment. So I'll just go ahead and create a new notebook for this and name it after this chapter as Introduction to Seaborn. Intro. Intro to Seaborn. So we have that. If I refresh now, you should be able to see it here. Well, I just want to go back a little bit and get some of the libraries that we've worked with so far. So over the course of our learning journey so far, over the last 50 something days, we've learned all about these libraries. So I'll just go ahead and paste it here. So I'll be working with these data sets. So we've learned all about this library. So I'm just going to add Seaborn to our lesson knowledge. So we have learned about matplotlib as pipe, the pipe plots, numpy pandas, all these different stats, statistical library, uniform, binom, norm, position, expon. So I'm going to add imports, Seaborn as SNS. If I run the code, so we shouldn't get any error. So it has actually imported all these libraries. So this is how we are going to work with the data sets and manipulate it anyhow we want, visualize it, do statistical analysis, or we structure the column, add new columns, and do whatever we need to do to the column. So that's the essence of all those libraries you are seeing above. So let's continue. So it says in this exercise, we use a data set that contains information about 227 countries. This data set has lots of interesting information on each country, such as the country's birth rate, death rate, and its gross domestic product, which is GDP. So GDP is the value of all the goods and services produced in a year, expressed as dollar per person. So we've created three lists of data from this data set to get you started. GDP. GDP is a list that contains the value of GDP per country expressed as dollars per person. Phones is a list of numbers of mobile. The next is to import. The next is to import max plots lib dot pyplots as PLC. Let's run the code. So we didn't get any error. So let's submit and see. Okay. So create a scatter plot with GDP on the x-axis and number of phones on the y-axis. So it says GDP is a list. So they just created a list for us. Create a scatter plot of GDP versus number of phones per 1,000 people phones. So it's going to be SNS dot scatter plots. So on the x-axis, we are going to have our GDP on the x-axis, comma on the y-axis, we are going to have phones. Then we just write plt.show. We need to show the plots. Voila. You can see the results here. So let me take a quick sneak peek back here. And just let me read uh the data set here also. So the data set is probably these countries of the world data sets. So we're going to change this, read countries of the world data. So I is it named here? Countries slash hyphen or dash of the world. Okay. Of the world. Let me double check that. Let's run it. If you run into error, probably just let me just change this to countries to make it easier. So I could just copy countries there. So you can take a sneak peek. Voila, you can see the information we have now. So this is the data set. It contains 227 rows of data and 20 columns, as it was mentioned here. So we're looking at information of over 200 countries. Let me just do dot edge. just to see a few rows of data there to make it easier. So we have the country, the region the country is located, the population of the country, the area in square meter, the population in density per square meter, the coastal area ratio, the immigration rate in the country, the mortality rate, infant mortality rate per 1,000 births. We have the GDP per capita, the literacy rates, the funds per 1,000 people in the country, the arable crops, other another information. Wow, this is a lot of data. I would love to take this into Power BI and Excel and see what we can do with it. But let's focus on Python for now. So in this scenario here, we actually chose, let me see, we, we took the scatter plots, just the funds and GDP column. Let's do that. So let's create it here and see if it is going to work. GDP is not defined. So if I look at GDP here, GDP is spelled capital letter here. GDP, what about funds? Mm, Phone is in capital letter too. The P is in capital letter. Ooh. I definitely need to mention. Let me just take a sneak peek back here. I need to point to the data. I know I need to point to the data. So the data will be equal to countries of the world. So let's point to the data set here. So it could know it will pick that information from that. Oh, it's just saying my GDP is not defined. Ooh. Okay, saying GDP per capita. Well, I have to hide the old names. Oh, interesting. Let's copy that and see it now in action. Okay. What about phones? So we really want to visualize those two records. Let's do it again. Ooh, it's picking this dollar sign here. So we have to rename the column. Hmm. What if I wrap this in quotes? Let me check. Okay. Let's wrap it in quotes to make it easier for it to differentiate that these are just names of the column. Voila. Can see we have the information about the naming, the information, the naming of the funds per year, blah blah stuff is just too much. So this is not a good visualization for now because of the axis labels. It's not showing well, but it's a good start. So that's just how it is. You just pick two random variable that you need to visualize and point towards it and point to the data set also. So let's continue and see. Now it says display the plot. I've done that. Oh, plt.u. plt.show. Oh, okay, I got pick, not show there. Voila, so we have same answer there. Quite straightforward. Change the scatter plot so it displays the percent of the population that can read and write. We should change it to show the percent of population that can read and write on the y-axis. Okay, so just change it to this column that we have here. Percent that can read and write. Let's run the code. You can see quite different here. So you can actually perform the same thing here also. Watch which information is showing us the percent population that can read and write. Oh, I don't have such information here. Hmm. So we don't have it here. So it's just similar to what we need to do here. So let's continue. Oh, all right. Why this plot does not show a linear relationship between GDP and percent literate? Countries with a lower GDP do seem more likely to have a lower percent of the population that can read and write. That's interesting. Okay, making a count plot with a list. Let's see what we have here. Because we have just a couple of lessons here to do today. It says in the last exercise, we explored a dataset that contains information about 227 countries. Let's do more exploration of this data, specifically how many countries are in each region of the world. To do this, we will need to use a count plot. Count plots take in a categorical list and return bars that represent the number of list entries per category. You can create one here using a list of regions for each country, which is a variable named region. Okay. We need to import Seaborn. Come on now. We can't be doing that over and over again. Okay, we've done that quite easily there. Now a create count plot with region on the y-axis. A count plot with region on the y-axis. Okay, that'll be SNS dot count plot. Then region, we just point to region here. Region, then we just show the plots. Let's see what we have here. Voila, can see the region Asia, and the region with the most countries is sub-Saharan Africa. Let's create same thing here in the Jupyter notebook. Now we're after the region. Let's go to the region area. Okay, let me go back a little bit. We can see the region record here. So I'll just change this to region. Let me see if it's going to work without pointing to the data set. Because region is not defined, so I need to point to the data source that it needs to use. If I point to that, now we have, come on, region Region. Region. Okay, let's add a code to that. Voila. You can see the region we have in the record. You can see the region we have here in this whole column. Over 200 record. But when you look at it, it's much more better. So we have in the sub-Saharan African, we have more countries in the region, then followed by Latin America and the Caribbeans, then followed by Asia. Hold on a second there. Followed by Asia. Then we have next is definitely the Western Europe and so on. You can see the data easily like that. Interesting. So let's continue. Let's submit and see. Good job. Sub-Saharan Africa contains the most countries in the list. We'll revisit counts plot later in the course. Okay, so now let's continue from there. Hold on a second, please. Oh, we'll be learning over the past couple of lessons using pandas with Seaborn. So let's see what we can learn in this lesson on using pandas with Seaborn. Let's cover one more lesson today using pandas with Seaborn, adding a third variable with ill. Okay.
Data scientists commonly use pandas to perform data analysis, so it's a huge advantage that Seaborn works extremely well with pandas' data structures. Let's see how this works. Pandas is a Python library for data analysis. It can easily read datasets from many types of files, including CSV and TXT files. Pandas supports several types of data structures, but the most common one is the data frame object. When you read in a dataset with pandas, you will create a data frame. Let's look at an example. First, import the pandas library as PD. Then, use the readCSV function to read the CSV file named masculinity.csv and create a pandas data frame called df. Calling head on the data frame will show us its first 5 rows. This dataset contains the result of a survey of adult men. We can see that it has 4 columns: participant ID, age, how masculine, which is that person's response to the question, how masculine or manly do you feel? And how important, which is the response to the question, how important is it to you that others see you as masculine? Now let's take a look at how to make a count plot with a data frame instead of a list of data. The first thing we'll do is import pandas, matplotlib, and Seaborn as we have in past examples. Then we'll create a pandas data frame called df from the masculinity CSV file. To create a count plot with a pandas data frame column instead of a list of data, set x equal to the name of the column in the data frame. In this case, we'll use the how masculine column. Then, we'll set the data parameter equal to our data frame, df. After calling plot.show, we can see that we have a nice count plot of the values in the how masculine column of our data. This plot shows us the most common response to the question, how masculine or manly do you feel, is somewhat, with very being the second most common response. Note also that because we're using a named column in the data frame, Seaborn automatically adds the name of the column as the x-axis label at the bottom. Let's pause for an important note here. Seaborn works great with pandas data frames, but only if the data frame is tidy. Tidy data means that each observation has its own row and each variable has its own column. The masculinity data frame shown here is tidy because each row is a survey response with one answer to each survey question in each column. Making a count plot with the how masculine column works just like passing in a list of that column's values. In contrast, here's an example of an untidy data frame made from the same survey on masculinity. In this untidy data frame, notice how each row doesn't contain the same information. Row 0 contains the age categories, rows 1 and 7 contain the question text, and the other rows contain summary data of the responses. This will not work well with Seaborn. Unlike the tidy data frame, values in the age column don't look like a list of age categories for each observation. Transforming untidy data frames into tidy ones is possible, but it's not in scope for this course. There are other DataCamp courses that can teach you how to do this. Now, it's time to try out using pandas with Seaborn.
Let's combine pandas and Seaborn in one lesson. It says tidy versus untidy data. Here we have a sample data set from a survey of children about their favorite animals. But can we use this data set as is with Seaborn? Let us use pandas to import the CSV file with the data collected from the survey and determine whether it is tidy, which is essential to having it work well with Seaborn. To get started, the file path to the CSV file has been assigned to the variable csv.filepath. Note that because csv underscore file path is a Python variable, you will not need to put quotation marks around it when you read the CSV. Okay. It says read the CSV file located as file path into a data frame named df. Okay, quite straightforward. df equals to pd dot read underscore csv. So print, then we print CSV file path. Let's run the code and see what we have here. Oh, mm, let's see. Oh, know where the error is coming from. Let's see. Oh, dot edge. I need to put dot edge. Df dot edge. Oh, I was also put df dot edge rather than that. So the first five rows is can see the first five rows there of the data. Marion, how old are you? Elroy, what is your favorite animal? Can see this is not properly it's not tidy. So let's submit. View the first five rows of the data frame. Is it tidy? Why or not? Yes, because there are no typos or missing. Yes, because it is well organized and easy. No, because a single column contains different type of information. So this is not tidy. That's quite straightforward. Making a count plot with a data frame. Let's say we can make a count plot with a data frame. Let's how to do that. So let's see that. So making a count plot. Let's say we can make a count plot on the survey question. In this exercise, we'll look at the responses to a survey sent out to young people. Our primary questions are is how many young people surveyed report being scared of spiders? Okay, how many young people surveyed report being scared of spiders? So survey participants were asked to agree or disagree with the statement. I'm afraid of spiders. Response vary from 1 to 5, where 1 is strongly disagree and 5 is strongly agree. To get started, the file path to the CSV file with the survey data has been assigned to the variable or CSV file path. Note that because CSV file path is a Python variable, you will not need to put quotation marks around it when you read the CSV. So import pandas and Seaborn. Come, we need to import pandas and Seaborn again. Let's see. So let's import pandas and Seaborn. That's create a data frame from the CSV file. So we want to create a data frame called data frame df equals to CSV, sorry, PD underscore PD dots not for CSV. And the file path is going to be CSV file paths. So create a count plot. So count plot is going to be SNS. I need to import matplotlib also. So I can create a count plot. Because I need SNS here. Okay, I have SNS already and I have matplotlib there already. So it's going to be SNS, that's Seaborn dot count plots. So my variable I want to visualize is equal to the spider column. Oh, great. So we need to point to the spider column here. Spider column. And the data we are pointing to is the df data frame. Then we're going to the plt dot show. Let's see what we have here. Vol, I can see the count, then spiders. So I think we need to name it properly also. I'm not seeing one. Okay, one is, it says one here is strongly disagree. So we have more people, more children that strongly disagree that they are afraid of spiders, then strongly agree that they are afraid of spiders is the next. Okay, let's continue. Awesome. This plot shows us that most young people report not being afraid of spiders. You can see, strongly disagree. So these are simple plots to create. Adding a third variable with hue. So let's do that with this last lesson.
We saw in the last lesson that a really nice advantage of Seaborn is that it works well with Pandas data frames. In this lesson, we'll see another big advantage that Seaborn offers, the ability to quickly add a third variable to your plots by adding color. To showcase this cool feature in Seaborn, we'll be using Seaborn's built-in TIPS dataset. You can access it by using the load dataset function in Seaborn and passing in the name of the dataset. These are the first 5 rows of the TIPS dataset. This dataset contains one row for each table served at a restaurant and has information about things like the bill amount, how many people were at the table, and when the table was served. Let's explore the relationship between the total bill and tip columns using a scatter plot. Here is the code to generate it. The total bill per table in dollars is on the x-axis, and the total tip in dollars is on the y-axis. We can see from this plot that larger bills are associated with larger tips. What if we want to see which of these data points are smokers versus non-smokers? Seaborn makes this super easy. You can set the hue parameter equal to the data frame column smoker, and then Seaborn will automatically color each point by whether they are a smoker. Plus, it will add a legend to the plot automatically. If you don't want to use pandas, you can set it equal to a list of values instead of a column name. Hue also allows you to assert more control over the ordering and coloring of each value. The hue order parameter takes in a list of values and will set the order of the values in the plot accordingly. Notice how the legend for smoker now lists yes before no. You can also control the colors assigned to each value using the palette parameter. This parameter takes in a dictionary, which is a data structure that has key value pairs. This dictionary should map the variable values to the colors you want to represent the value. Here, we create a dictionary called hue colors that maps the value yes to the color black and the value no to the color red. When we set hue equal to smoker and the palette parameter equal to this dictionary, we have a scatter plot where smokers are represented with black dots and non-smokers are represented with red dots. In the last example, we use the words black and red to define what the hue colors should be. This only works for a small set of color names that are defined by matplotlib. Here is the list of matplotlib colors and their names. Note that you can use a single letter matplotlib abbreviation instead of the full name. You can also use an HTML color hex code instead of the matplotlib color names, which allows you to choose any color you want to. Here's an example using HTML hex codes. Make sure you put the hex codes in quotes with a # at the beginning. As a final note, hue is available in most of Seaborn's plot types. For example, this count plot shows the number of observations we have for smokers versus non-smokers, and setting hue equal to sex divides these bars into subgroups of males versus females. From this plot, we can see that males outnumber females among both smokers and non-smokers in this dataset. We'll be using hue a lot in this course, so let's practice what we've learned to round out the first chapter.
Oh, great. So let's practice all of it in one lesson. So hue and scatter plot. So in the prior video, we learned how hue allows us to easily make subgroups within Seaborn plots. Let's try it out by exploring data from students in secondary school. We have a lot of information about each student, like their age, where they live, their study habits, and their extracurricular activities. For now, we'll look at the relationship between the number of absence they have in school and their final grade in the course, segmented by where the students live, rural versus urban area. Oh, interesting. We have our matplotlib and Seaborn already. Let's create a scatter plot. It's going to be SNS dot scatter plots. So open bracket, our x-axis. So absence of the x-axis, comma, our y-axis, and that is the final grade on the y-axis. Use the data frame student data. So the data frame we're using for this is student data. Then now, they ask us to include to color the plus point based on location. Okay, you can say location. U will just be equal to location. Let's run the code and see. Oh, great. You can see the final grade and number of absence. Oh, even those that are actually more present in school, their grade is not as high as those that were more absent in school. Interesting. Make rural appear before urban in the plot legends. Okay. I'm going to say EU location. It's a change the legend order in the order in the scatter plots. Location is zero. Let's see how to do that. Oh, then we need to have a list with the colors. How can we have a list with the color though? Okay, I'll just location is equal to. So we want Want rural to come first. So rural is going to be, so rural is going to be blue. And comma, then urban, that is going to be orange, definitely orange. Yeah? Let's go for orange. Let's say if orange is a color though in the list, I doubt. Let me change this one to red then. The chart, oh, it's giving me four results. Ooh. We're supposed to be seeing this my location here though. Oh, all I have to do is just change the E order. I don't have to create a list, a new list entirely. I could just come here and say E order. Oh, that's my mistake there. I'll just order the E, which is going to be equal to open brackets. Rural is going to come first, comma, followed by urban. That's all I need to do there. Okay, that's all we need to do. Oh, E order is giving me error, so I need a comma there. Let's only go it again. Uh-oh. Ah, there's an error somewhere. Even though it is still correct, you can see. So you can see why is coming before urban. Okay, just have to change the order. Well done. It looks like students with higher absence tend to have lower grades in both rural and urban area. You can see with higher absence, tend to have lower grades here in both rural and urban area. How about those with lower absence? Lower absence too tend to have higher grades too. So it's vice versa. So EU and count plots. So let's continue exploring our data sets from students in secondary school by looking at a new variable. The school column indicates the initials of which school the student attended, e.g., GP or MS. In the last exercise, we created a scatter plot where the plot points were colored based on whether the student lived in an urban or rural area. How many students live in urban versus rural areas? And does this vary based on what school the student attends? Let's make a count plot with subgroups to find out. Okay. It says fill in the palette colors dictionary to map the rural location value to the color green. Rural to green. Okay. I just copy this. That's what I was trying to do earlier there. And rural to green and open location to blue. Urban location to blue. So create a count plots. Let's create a count plots of school within location subgroups. Oh, let's how to do that. There's going to be SNS dot count SNS dot count plots. We school on the x-axis. Then we input school here. And our data point is going to be our data point is going to be student data frame. Going to be student data frame. Then say add subgroups to deploy using location variable and use the palette color dictionary to make the location subgroup green and blue. Okay, let's see how to do that. We shall have subgroups. Let's see. Hmm, okay, so E is going to be equals to location. The now is going to be location. Our location. Hmm. You say add subgroups to the deploy using location variable and use the palette colors dictionary to make the location subgroups green and blue. How do you add subgroups to this situation? Let's see that. I'm going to go for palette colors here. Palette underscore colors. So probably we're having it says add subgroups to deploy using the location variable. So okay, location variable. Then our palette color. Let's see, comma palettes will now be equal to palette colors. Let's see if this works. Ooh, let's get up on this finally to solve this challenge. Where is coming from rural green, blue urban. Oh, it's supposed to be urban here. Let's run the code again. Voila. So we know that you can see our location is the subgroup urban, and so we made the location to be green and blue based on the palette color. Interesting. Awesome. So students at GP tend to come from an urban location, but students at MS are more evenly split. Congratulations on finishing chapter one. Interesting. So we need this chapter one in under 1 hour in the live stream. Interesting. So the number of lesson there is quite short, so we can actually finish it in an hour. So introduction to relational plot and subplots. can see that the lessons there is quite much. We may have to do this in a couple of probably two, three live streams. Let's say one and two live streams. Great. So we've learned all about Seaborn today and got introduced to Seaborn and how to plot simple data visualization using Seaborn. So that will be the end of the live stream for today. I'll see you tomorrow, which is day 54, as we continue this uh, data visualization with Seaborn on our Python learning journey. Do have a wonderful rest of the day. Let's get back to work. I'll see you tomorrow.